25 Celsius degree.
Oh, 25. Something
Yeah.
like in East Nusa Tenggara province, commonly in Indonesian is the high season. Uh,
Uh, Thank you. You you have some colleague like graduate. Yeah, good, good.
yeah.
Me too. Mhm.
Prof. Prof. Our college is actually IT
Oh,
college,
see.
the first IT college,
Yeah.
and the oldest as well. It's been 25 years now, the college, yes.
Mhm.
So this is why we contacted you from
That-
February, because we do believe that your background, your passion about data can give like a big contribution for us all. Yes.
I voice seems
Okay.
like
Uh, the voice is good.
yeah,
The,
your voice was
uh,
Oke, Bapak Ignas mungkin bisa ngobrol sama Prof. Kewei. Prof, we will, I think we are about to start our seminar. We are waiting for students to join us in the auditorium. So please bear with us. And perhaps while waiting, you can talk or speak with our former chairperson. Pak Ignas and Pak Kewei, the time is yours.
okay.
okay.
So I ask so one question to my homework in colleague about the artificial automatic IoT and I
The connection was not great. I missed some of your words there.
yeah, it is not good.
Warahmatullahi wabarakatuh. Salve, Shalom, Om Swastiastu, Namo Buddhaya, salam kebajikan, selamat pagi untuk kita semua. Yang terhormat Bapak Ketua Yayasan Bapak Ketua Stikom Uyelindo Kupang bersama jajaran pimpinan, keluarga besar Civitas Akademika, para dosen tendik, dan mahasiswa Stikom Uyelindo Kupang, keluarga besar Uyelindo Group, singkatnya hadirin yang kami muliakan. Selamat pagi dan selamat datang di seminar internasional kita di pagi hari ini. Karena ini seminar internasional, maka izinkan saya memandu acara ini dalam bahasa Inggris. So, good morning, ladies and gentlemen. Good morning, Prof. Kewei.
Good morning.
Say hi to Prof. Kewei. Hi, Prof.
Hi.
Okay, welcome to our international seminar, the first international seminar of the year here at Stikom Uyelindo Kupang. I am Maria Katarina Cindriani and I have the honor of being your master of ceremony for today's exciting seminar, an exciting exploration into the intelligent world of IoT and data-driven decision making. Before we begin our seminar, let us take a moment to express our gratitude to the God Almighty. So let us take a brief moment to pray. I would like to respectfully invite Mrs. Henny to lead us in prayer. Mrs. Henny, the floor is yours.
Okay, let us bow our head and let me lead this prayer into my faith, Catholic. In the name of Father and Son and Holy Spirit, amen. Heavenly Father, we gather here today with grateful heart for the opportunity to meet, learn, and share knowledge at this international seminar on computer science and technology. Thank you for bringing together brilliant minds and passionate hearts from around the world to advance our understanding and contribute to the society through innovation. We ask for your guidance throughout this seminar. May our discussion be fruitful, our mind be open, and our heart be inspired. Bless the speaker, participant, organizer, and all those who made this event possible. Grant us the wisdom to use our knowledge responsibly, ethically, and for the good of humanity. May this seminar be a source of collaboration, discovery, and growth. May we live here more informed, more connected, and more committed to make a positive impact in the field of computer science. We entrust this seminar to your loving hands. May your Holy Spirit inspire us throughout this event so that all our work may ultimately give glory to you and contribute to the common good. We ask this through Christ our Lord. Amen. In the name of Father, Son, and Holy Spirit. Amen.
Tepuk tangan dulu dong. Thank you, Mrs. Henny. All right. Now, to give the official welcome address, I would like to kindly invite the head of Stikom Uyelindo Kupang, Dr. Remerta Naatonis, to share a few words with us. Please give a warm round of applause.
Okay, thank you, Mrs. Maria. Good morning, Prof. Sa.
Morning.
Good morning, Prof. Thank you for your coming with Zoom meeting today. Good evening, yeah. Good evening. Sorry, good evening, Prof. Because time USA and good evening, yeah. Okay. And good morning, dear participant, yeah, lecturer and student of Stikom Uyelindo Kupang, and dear participant from Malaysia, Saudi Arabia, Timor Leste, and USA. On behalf of Stikom Uyelindo Kupang, it is my great pleasure to welcome all of you to this international seminar from data to decision, how IoT provides smart solution, how to identify user using a small amount of data. We are thrilled and honored to host such an important event that brings together academics, professional, and a student here at STICOM Welindo Kupang. I would like to send my gratitude towards Prof. Sa from North Texas University. Thank you very much, Prof, for willing to do this for us. This is such an honor. We can hear and learning from your incredible work and achievement. Your amazing experience and expertise will be an excellent addition to our study program. Also, thank you very much for each and every one of you who are coming and begin with us in this seminar. I strongly believe that this seminar international is not only a platform for sharing knowledge and ideas, but also a break that connects culture, disciplines, and innovation. I hope that today's discussion will inspire new perspective, yeah, faster collaboration, and contribute meaningfully to our field of study and practice. Again, thank you very much, Prof. Sa, for doing this for us all. I know that it's evening now in the United States, but we appreciate to you as you still want to do this. Thank you very much for being an important part of this event. Thank you, thank you, thank you very much.
All right. Thank you very
Thank
much,
you.
Mr. Ray. Tepuk tangan. Please give a warm applause for the head of Sikom Indo Kupang, Dr. Ray. Terima kasih Bapak Ketua. All right. Without further ado, I know that you are waiting for us for so long, Prof. Kewei, and we are sorry for that. We apologize for that. So let our international seminar begin. I would like to give the floor to our amazing moderator, Mr. Yampi Kaismetan MCom, who will guide us through today's seminar. Mr. Yampi, the session is yours. Tepuk tangan dulu teman-teman. Terima kasih.
Okay, thank you, Mrs. Cindy. Yeah, good morning, everyone. Good evening, Prof. K. Yeah. Okay, welcome to our international seminar. The topic is From Data to Decision. A big hello to all of you joining us here in the room and just watching online via Zoom. We are so glad you are here. Today, we are learning how to turn data into smart decision. Our speaker is expert in this field, and he will share his knowledge with us. Even though our main speakers is join us all of the way from Texas, USA. Yeah, we give applause to Prof. Kewei. Okay, we are all connected today to discuss this important topic together. Let's welcome and our honor speakers, Prof. Kewei Sa, PhD from the University of Texas, USA. Prof. Kewei is a leading expert in cutting-edge tech like data science, cyber security, blockchain, and IoT. He's not just a professor, he's also a top research with 5 million in funded project, yeah, including NASA and NSV, an editor top tech journal, yeah, and award-winning leader in computer science. So let's give a big round of applause for Prof. Kewei. All right, let's get started. Enjoy the seminar and let's learning something great today. The time is yours, Prof. Kewei.
Okay, thank you. And okay, I can share the screen, right? Okay, so
Yeah.
thank you for having me here, and thank you all for your nice introduction. Okay, it's my honor to talk about my recent work, okay, in this international seminar. Okay, so that's a great honor for me. Okay, I'm Kewei and I'm associate professor of data science uh, from the Anu and Vikas Sinha Department of Data Science at the University of North Texas. I'm also the director of data science programs. So today I will talk about from data to decision, right? So that's a topic of your seminar, and I will talk about how we perform efficient and quality-aware data analytics. Okay, so this is the agenda of my talk. So firstly, I will give a brief introduction about some of the background, and then I will talk about two our recent work. One was lightweight, quality-aware data analytics. So the other is edge computing-based optimization. So both targets to improve the efficiency in the data analytics. Okay, so finally, I will provide some conclusion of my talk. Okay, so first, we know that nowadays, so big data so has been there for a while, and recently, like large language model, generative AI, getting very popular. So all this happened because of we have huge amount of data to analyze and to learn from huge amount of data, right? So you see, so all the data may come from many sources, including like social medias. I'm not sure if in Indonesia you use all these apps, but here in United States, so we use all these apps like Facebook, Instagram, Twitter, and YouTube, right? And so many others. Okay, and also huge amount of data coming from like top online retailers, including like Amazon, Alibaba, Walmart, Target, and so on. Okay, so this data is made already be outdated, but nowadays we definitely will see much more data than what we see here. Okay, and also from Internet of Things. Okay, so Internet of Things, they have small devices. Each of them generate like data streams. Okay, for each of them, they already generate a big amount of data, but considering the scale of Internet of Things, then altogether they will generate a huge amount of data, right? And then nowadays, so when we talk about autonomous driving and autonomous vehicles, and you see that, so each autonomous vehicle will generate 4,000 gigabyte data. They will be will be huge amount of data for us to analyze. And then definitely in healthcare, okay, so there's huge amount of data, okay, and all the data may come from the generic database, may come from like a lab work, may come from like a public records, come from like a smartphone apps, wearable devices, and so on. Okay, so definitely, so we are living in a world that is full of data, and definitely, so we facing significant challenges. How can we efficiently analyze data? Okay, and in addition to that, okay, so when we talk about data and the bigger data, right? So that's what we see, okay, but sometimes the, because of like the privacy concerns or many other concerns, and then we might have to make a decision based on local data. So that means that sometimes we might have to make a decision based on small amount of data, even though so our analysis could towards to like larger scale data, massive data, right? So then you see that. So we have a lot of challenges for the data analysis. I think there's some echo. Okay, thank you. Okay, so these challenges, I just list, okay, uh, uh, several like significant challenges, okay? But they are already like bring us a lot of research problems that we can try to handle, okay? So as I mentioned just now, yes, there are large amount of data, but a lot sometimes, so we have to make a decision not only based on the large amount of data, but sometimes we have to make a decision based on a small amount of data. If that's the case, then how can we make a wise decision? Okay. And secondly, so definitely there's a heterogeneous types of data with multimodality. So think about we have data, text data, we have numerical data, we have image data, we have like cloud point data, we have all kinds of data. We have video, audio, and then how can we efficiently analyze this type of data? Okay. And then we're also facing some challenges, like we have to perform the real-time data analysis. For example, the application we mentioned just now, like the autonomous driving, right? In autonomous driving, you have to make decisions in real time. Okay, otherwise, then bad things could already happen before you get the data analysis result. And a lot of time, this kind of analysis will be performed in the resource constrained devices. So even we think like a vehicle is a pretty like a resource rich, powerful device, but still the resource is really limited because the vehicle has to perform multiple tasks. Okay, so that brings us many challenges of how we design the algorithms for accurate data analysis. Okay, how to manage the quality of both raw data or the features extracted from the data. So the quality is very important. Okay. In addition to that, we might have some issues like data inaccessibility issue, data security, data privacy issue, right? So all these are the challenges. So in today's talk, I would like to focus on the first five. Of course, there's many other like challenges. Okay, in addition to this list, but I believe, okay, so this list, okay, are the most significant challenges we are facing right now. And today, so I will focus on how to provide like efficient and quality aware data analytics. Okay, so this is today's talk. Okay, and then I will introduce to our recent work. Okay, the first one is a lightweight, quality-aware data analytics. So we work in the application of biometrics-based user identification. Okay, so I believe you may heard of like a biometrics-based user identification. So that is to use unique biological characteristics to identify a user or a person. So generally speaking, so there are two types of like biological characteristics we make use of to identify a user or a person. So one is like a physiological, uh, biomedical characteristics. So such as like iris, okay, such as the DNA, such as a fingerprint. I believe you are use fingerprint a lot, right? And if you are using like a smartphone and they're using like a face recognition, okay? So face recognition based authentication. All these okay, examples of uh, physiological biomedical characteristics for user identification. Okay, in addition to that, so we also have behavioral user identification approaches. For example, like each user may have a unique like voice patterns, right? And each user may have like unique gait features. Okay, each one has a unique like signature patterns and so on. So these are called behavioral uh, biological characteristics. So they can also be used to uniquely identify some users. Okay. So the good thing of the biometrical based user uh, characteristics to identify user includes, okay, so these are whatever like physiological or behavioral like biomedical characteristics. So they are naturally a part of the user, right? So you will not lose them, okay? And it's not like a password. Okay, you set this up, and or if it's a key, so you may forget that. Password can be forgot, key can key can be forgot, but this kind of biological characteristics you carry it with you all the time. Okay, and also they can be highly unique to each individual. So you might heard some sentence such as like each like leaf has a different pet, right? So therefore, so they can be used to uniquely identify individuals, and it can not be forgotten and harder to be fogged. Okay, so of course, so there are some like attacks, right, to try to mimic the voice, especially nowadays with the generative AI. Okay, so we're facing more challenge. Okay, these like biological characteristics to be fogged, but still there's some algorithm can be used to detect. Okay, so one of our recent work is try to detect some fogged biological characteristics like ECG signals. Okay, and another thing is a lot of time. So these characteristics, okay, are easily verifiable. So therefore, so there's wide applications such as a fingerprint. So on like my Mac, I a lot of time I just use the fingerprint to do authentication to unlock my Mac, right? On my smartphone, I just use the face recognition to unlock my smartphone, okay? And then in terms of like a voice or signature, so yes, so these are can be used, okay, to verify the legitimate of the user. So that's why, okay, so we feel interested, okay, to use the biometrics to identify the user, okay? And then we did the two work, okay? So one work is we based on the working pattern to identify users. So the other is we use the keystroke. So this is the patterns of your how you type to identify the user. Okay, so then these using walking or keystroke patterns, the advantage is they can continuously identify the user, and they are also less intrusive. Okay, because they will not require users interaction. Okay, and also they are cost effective and affordable since okay, so a lot of people nowadays they have like smartwatch, right? So we can make use of the sensors from the smartwatch to detect your working pattern. Okay, so the other is so when you are typing and in the keyboard, naturally, so keyboard is everywhere. So we can tell whether it's you or someone else are typing right now. Okay, but there are some challenges, right? So one is we need to do like real-time identification. Okay, so you based on the like your biomedical data.
Sering di kampus dong nonton ini lah ini.
Okay, then okay, so we have to do the real-time identification. That means we might have to identify a user using a very small data set. For example, like 2 second, 3 second, this amount of data. Secondly, so there will be limited computing resources. You know that, so the detection could be made on the phone, on the smartwatch, or the detection could be on a smart key sources. And three, we need to have high accurate detection algorithms. Okay, so we need to achieve very high accuracy. Otherwise, this kind of algorithm may not work. So therefore, so we design our solution to tackle these challenges. Okay, so then in one work, so we propose ACT ID framework. So that is list activity sensor-based user identification. So this has two phases, right? It's like a typical like data analytics or classification project. Okay, so you have some sensors where at your risk, like a smartwatch, and then they collect activity data. So this activity data will go through the processing, like filtering, interpolation, and resampling, and then they extract the features. Okay, so these features could be both statistical features or physical features. And then these features, since so many features can be used here, right? So then we have to perform some feature selection and the feature evaluation and the selection. So we select a set of high quality features, and then based on these features, we will we will train like classifiers.
Penyampaian laporan
And the machine learning models. And then later on, the data is collected again from the user, so we can use these trained models to identify who is which user. Okay, so these are the two phases. And then how the data is collected. So you see, so we just use a very simple sensor. So they sense, they have two sensors on this device, like accelerometer and a gyroscope. Okay, so they sample at 100 hertz. Okay, and this is how the data look like. Okay, so we collected data from 30 different users. Of course, the majority of them are college students. So actually, so this make this task more challenging. Why? Because these users could be similar to each other. Okay, and for each user, we collected 2 sessions of data. Okay, one is for training, the other is for testing. Okay, so each session of data is 60-second data. Okay, so this is how the data look like, raw data. Okay, and if we plot the data, this is how the data look like. Okay, then from the data, we extract features, right? So based on the published literature, so there's 17 popular features, but each feature can be measured on all 6 dimensions because we have 2 sensors. Okay, each sensor has X, Y, Z, 3 dimensions. So therefore, in total, we can generate 96 features. And we know that 96 features is too many, right? So if we try to do the classification based on 96 features, not only so the result might not be good, one thing. Secondly, so that will make the algorithm a lot more complicated. Okay, so but we want to have very lightweight algorithm. One is for real-time requirements. Second is to satisfy the resource constraints. So therefore, we have to do feature evaluation and the selection. Okay, so we propose an approach. So this is called the optimal feature evaluation and the selection method. Okay, so we will evaluate the feature with two our defined metrics. One is called the furnace values, the other is called the furnace ratio to select top ranked features. We don't need all 96, that's too many, okay? So we only select a set of high quality features to achieve better like analytics result, okay? And secondly, okay, we use the sensor reduction method. And we mentioned there are two sensors, right? So in our argument, so we would like to use as less number of sensors as possible. Why? Because one is the cost. The less number of sensors we use, the lower the cost. Secondly, so each sensor may need calibration, right? They have data quality issue. Okay, so if we can reduce the number of sensors, so actually that helps us to do better detection. Okay, so therefore we try to reduce the number of sensors. Okay, so in addition to that, we make use of some correlation method, perform the correlation analysis to remove some correlated features. Okay, so that's what we have done. Okay, so one of the optimal feature evaluation and the selection method, I can talk a little more about that. The goal of this method is to find a minimum set of high quality features that can distinctly differentiate any two users. So that's a goal. Okay, with this goal, so we define uh, some measure that is called normalized root mean square difference. Okay, so this is used to measure the similarity level between any two sets of data. Okay, so we have two sets of data set A, data set B, and each data set is a set of data points. Okay, so we define this to measure the similarity level between two sets. Okay, and then based on this definition, so each pair of the users, we can calculate one like this value, right? But then we have n users. So therefore, so
Recording in
there
progress.
are n times n minus 1 pairs, right? Or n times n pair. Okay, if you also have a like a pair between you and yourself. So remember that we collect two sessions of data, okay, before. So then we can generate NRMSD maps, okay? So this is how the map look like. If you look at the slides at the right bottom corner, so this is how the NRMSD map look like, okay? So then if we look at these maps closely, we had some observation. So the first observation is if the color of the elements is closer or to darker than the diagonals elements. Okay, so we can use this to evaluate each feature, right? So if like a map look like, okay, the figure 1A here, then that means this feature will not be a very good feature, okay? Instead, okay, what could be a high quality feature, a good feature? So if the NRMSD map can look like what we show you here in 1B. So this is a better feature than 1A, okay? And the other observation we have is if we aggregate, okay, two or more high quality feature, okay, then you look at this map, okay, so this map get stressed. Why? Because you see that all the diagonal cells in this matrix getting a darker color than others, right? So that means, okay, so the quality of these features enhanced, okay? But if we combine like multiple like one like low quality features and then even combine low quality feature with some high quality feature, then we will get a map look like what we see in 2.b. So this will not, okay, not good to be used to differentiate to any two person. So based on this observation, and then we can define some metrics to measure these maps. What kind of features are high quality feature, and then how can we combine like these high quality features in our algorithm, so that will help us to achieve high accuracy. So that's what we have done, okay? So to do this, we define two metrics. One is called the fairness value, the other is called the fairness ratio. So basically, so these are the metrics for us to evaluate the NRMSD map, okay? And based on this evaluation, we can select high quality features, okay? So basically, the bigger these two values, the higher the quality of the features. So therefore, so we don't need like 96 features. So we can only use like 10 or 8 or even 6 features, we can achieve very high accuracy. Okay? Then both based on that, so then we design a sliding window voter classifier. So this classifier is designed like this because we only have a very small amount of data. So our strategy is we try to reuse, okay, so these data points, right? So how we reuse these data points is we use sliding window, okay? So then we need to determine the optimal sliding window size and the sliding interval, okay? So this is our task. And the secondary, so all the samples to be classified will be fit in segment into different windows, right? And then for then each window will be input, okay, to a classifier. So here we say like we use traditional classifier, but it's not necessary, okay? So we can use like a more like a powerful classifier. But here why we choose like traditional classifier, that is because we want to achieve like good real time and within the resource constraints. So therefore, we just choose like traditional, like lightweight classifiers. Okay. So yes, I know like people talking about like a transformer, talking about like convolutional neural network, talking about like recurrent neural network or like large language model. Okay, yes, we have some students working on these kind of models, but these kind of model is not like like good for all the application. For example, for this application, we found okay the traditional classifier may be a better choice than these like CNN, RNN, or transformer based models. Okay, then for each like window, so you are classified by the traditional by the classifier, you will get a label. The label will be the identity of the user, and then for different window, each of them you get a label. So we aggregate all the labels to generate the final label who you are. Okay, so this is the design of our classifier. Okay, so then let's show some results. So our feature evaluation and the selection mechanism compared with some other like a popular feature selection algorithm, and we found that okay, so our feature selection method can only can use all the feature only based on one sensor, accelerometer. We don't need to have multiple sensors. But the other approach, so they will select the feature from multiple sensors. Okay, so this is one thing. Secondly, so we can see that our feature selection is more like scalable. Okay, so the performance will be more consistent with regard to the increasing of the number of the users. Like other approach, so with the increasing of the user, so the performance degrades. Okay, so then we're pretty confident that our feature selection algorithm works well. Okay. And we also evaluate the performance of our classifier. So we tested our classifier with different traditional like classification models, such as the KNN, Bayesian, IFC, and SVM. And we found SVM has a better performance. And I already answered why we don't want to use like CNN, INN transformer, this kind of model, because they are too heavy. Okay. And we found that, okay, use SVM and with a sliding window approach. So with very limited amount of data, like less than 10-second data, so we can achieve the accuracy of 100% to identify like 30 different users. So I think this is a pretty good result. Okay. So this is an example. We want to show that, okay, yes, we are excited about like big data. We're excited about like complicated models. Okay, but still in many applications, actually like small models and make a decision based on small amount of data. It's very interesting. Okay, so this is one of the work we want to share with you. Okay. And similarly, so we just now we analyzed the like working pattern. Okay, so we did another work analyzing keystroke. Okay, so why we want to work on this, because we found that okay, uh, right now most applications using password-based authentication. Okay, or use like two-phase authentication. Two-phase authentication is so popular nowadays, right? And then the password-based authentication, the problem is, so password, okay, yes, we definitely need to use strong password, but it's still not sufficient because the password could be stolen or could be exposed. Okay. If that's the case, then what do you do? Yes, definitely you say, yeah, we have two-phase authentication. But what if, okay, you change the device? Okay. We face this problem personally, right? So after I change my like phone and all my like two-phase authentication stopped working. Okay. Oh, you forgot your phone. Okay, then what can we do, right? So then we come out to some solution saying, okay, yes, instead of like a password plus like a second phase of authentication, then how about we use password plus like biometrics? So we use like a keystroke. Of course, so your password need to be correct. Okay, even though your password is correct, but your biometrics, your keystroke is not recognized as your keystroke, then you will not be authenticated. Okay, then how we use keystroke. Okay, so to identify a user, then definitely we need to define some features, right? So we define two features as dynamics. So one is called the dwelling time, that is the duration that a key is pressed. The other is called the flight time, the duration between the keystroke. Okay, then we develop similarly we develop some statistical models. Okay, to classify basically a user, it's this user is you or not you. Okay, so based on our evaluation, so we can prevent unauthorized 100% of like uh, uh, not right key striker patterns. Okay, but this is another work, but the motivation is similar to the previous work. Okay, we use very lightweight algorithm. Okay, to do the classification. Okay, so this is my first part. Okay, so like identify users using very small amount of data, using the very resource constrained devices, pretty much like IoT devices, right? And then I would like to introduce, okay, in addition to the innovation or advance of the algorithm, then we can also do optimization in our system, okay, in our architecture. So this goes to the second part of my talk, that is edge computing. So this is a layer to optimize data analytics, okay? So I'm not sure, Maria, so how much, how time I have for,
Okay, thank you, Prof. Kewei. Yeah, a very insightful
uh-huh.
presentation. Oh, maybe you have 10 minutes again for
10
the,
minutes.
yeah,
Okay,
10 minutes.
good. I will finish. Yeah, I will finish everything
Okay.
in 10 minutes then. Okay, 10 minutes. Thank you. Okay, so then, so this time we pick up application. This is called the video analysis. Okay, so video analysis is to recognize the users by analyzing the video streams. And we know that. So to analyze the videos, this will be like more challenging than analyze like a simple pattern, right? And also the data, amount of data we may obtain will be a lot more than the sensory data. Okay, so then how can we perform this task very efficiently? Okay, so then we see that, okay, so it depends on several choices. One is the choice of analytics models, right? So some of the model, okay, like a deep neural network based model, it has higher accuracy but more resource demanding. Okay, and there are some lightweight neural uh, network models. Okay, they are relatively resource less resource demanding, but they have lower accuracy. Okay, and then this is one kind of choice we need to make. The other choice is where we go to deploy the video analysis. We can do it in the cloud. We can do it on the edge. Okay, but on the cloud, the problem is heavy communication cost and delay. Okay, on the edge, so uh, there might not be sufficient resources to support like heavy deep neural networks models. Okay, then how can we solve this? Okay, and in addition to that, we have to handle like a dynamic and unpredictable communication channels. Like in today's meeting, we have seen that sometimes the communication is not so great, right? We heard some like a broken voice. Okay, so basically, so our research is try to handle, okay, these challenges. Okay, so we introduced two work. Okay, one is called M-Video. So basically, so we divide the video analytics task into multiple subtasks. Some of the tasks, okay, may be sufficient to use later, more lightweight deep neural networks. Some of the tasks may require like a heavy, like deep, deep neural networks. Okay, so then, okay, so we have divided the task into two subtasks. One is called the face detection. So detect the face, okay, not less challenging, but do the face recognition will be a lot more challenging. Okay, so therefore we use different network, deep neural network. One is a lightweight MTCCN for the face detection. The second is using the FaceNet, heavy deep neural network for the face recognition. And then one model will be deployed on the edge, and the other model will be deployed in the cloud because they have different available like resources. And then in addition to that, we try to optimize the data transmission from the edge to the cloud to achieve very good performance. So that's the main idea. Okay, so therefore, so we design a set of like software stack at the edge and a software stack at the cloud, and we design some like optimal communication protocol between edge and the cloud. Okay, and then we found that yes, we're using our approach, we can significantly reduce the amount of data need to be transmitted from the edge to the cloud, and significantly reduce the delay, and also reduce the power consumption. So this is one of the work. And the other work is we further, okay, investigate, we found that, okay, we actually don't need to send all the data to the cloud. And also we want to keep the human in the loop. Okay, so then what we did was, okay, so we enable the end user to decide, okay, what are the expected video content. For example, if you are interested in like some traffic sign, or if you are interested in like specific objects, okay, for example, in the like if you are only interested in road construction, right? So you may only need so road construction related objects to be detected. So this kind of things, we say this is called region of interest, ROA. So you go to use it, go to define the ROA, and then at the edge, so we can do a lot of like early processing to identify, okay, your ROA, and then send the ROA data to the cloud to further analysis. Okay, and then in this way, so we can significantly reduce the amount of data need to be transmitted. And also we design some adaptive protocol to adapt to the various network conditions. If you have strong network connection at this moment, and then we can afford to send more data, okay? Otherwise, we will send less amount of the data, okay? So then we design this, okay, this is our architecture. So how the edge and the cloud and the end user, how they interact each other to support different applications, okay? And then we implement this as, okay, so at the edge, we have like data acquisition module, and then we have edge computing node, we have like edge software stack, a bunch of module implemented at the edge. And then at the cloud, so or at the application layer, we have like end user modules, okay? And then we did some establish a test bed, including some cameras and edge device, server as server work as a cloud, and then the clients make use of like workstation or pad or smartphone. Okay, so then we tested our developed the system and all the protocols, and we found that okay, we can significantly reduce the communication cost and also reduce the delay. And we also compare our approach with a popular approach called the real-time phase. Okay, so this approach, they're also performing the similar task as what we supposed to perform. And we found that our design outperforms their solution. Okay. So in conclusion, so we found that, okay, so data become the lifeblood of modern business and organizations. So we are living in a society now, okay, fueled by the data. So that's true, right? That's why we got a large language model and so many things, okay? And there's emerging technology such as federated learning, edge computing, generative AI. Of course, these are just a subset. So these technology empowered us for data analytics and data sharing. Okay, so I presented our recent research work in lightweight and quality aware data analytics. Okay, two different type of work. And definitely a lot more research are needed to secure, optimize the data sharing analysis process. Okay, so these presented work we published in like 4 journals and one conference. Okay, I think that's about my talk. And so if you have any questions, so feel free to ask questions.
Okay, thank you so much, Prof. Kewei. Very insightful for us. We know about the topic on this day. So we come to Q&A session. For the those online, please feel free to type your question in the chat box. And for everyone here in the room, yeah, let's keep our microphone for raise hand and ask your questions. Dengan bagian yang lain yang bisa diolah untuk bisa menggunakan metode-metode tertentu sehingga mendapatkan satu yang mau ditanyakan boleh. Bisa bertanya dalam bahasa Indonesia, nanti kita coba untuk translate Inggris. Silakan, ada satu. Sebutkan nama, ada 2, nama dan ya ada 3 pertanyaan. Kita excuse me, Prof. Kewei, because I'm using bahasa, I can translate in English. Oke, silakan.
Okay, good morning everyone. I'm Delphi Green Agustin Tonak from Informatic Engineering major. I want to ask a question about biometric-based user identification. What are the challenges related to failure to enroll in biometric system, and what factor can contribute to this issue, and how should system designer address them?
Oke, tepuk tangan dulu dong. Thank you.
I'm sorry, so can you repeat your question? I didn't hear
Okay,
very
sorry,
clear.
Prof. She's speaking too fast, I think. She's nervous, probably. I'm just kidding.
Oh.
I'm just kidding. Okay. Can you please repeat? Just speak slowly, okay? Take a deep breath.
Check.
And then, yeah, okay, go ahead.
Okay, I want to ask about biometric-based user identification. What are the challenges related to failure enroll in biometric system, and what factor can contribute to this issue, and how should system designer address them?
Okay, thank you. Prof. Kewei, can you catch that question?
Yeah, I think your question is how we measure the features, or what are the challenges there?
Yes, what are the challenges?
The
Yes,
challenges
and
like in the
how
features
should system
selection,
design?
or the challenges in the user identification?
Yes, and then how should system designer address them?
How system
Oh,
designer should address
Address them.
them.
okay. So like I think in my presentation, so I mentioned that there are a couple of challenges, right? So one challenge was like you only have very small amount of data. Okay. Second challenge is you have to make real-time decisions. And the third challenge is you only have like a very limited amount of resources to do the computation. Okay. So then how we address these challenges is one is we design like a very lightweight algorithm. Okay, so one is this algorithm has to be very lightweight. Secondly, so we have to make a decision based on very small amount of data. Then our solution is to reuse some of the data. Okay. And the other is, so we want to make it lightweight. So therefore, we cannot have too many features used in our algorithm. So we significantly reduce the number of features from like close to 100 to less than 10. Okay. So we can even only use like 6 features. But then you cannot use like low quality features. You have to select high quality features, right? Then again, so select a high quality feature itself is a challenge. So therefore, so we design a feature selection and evaluation and the selection mechanism to select high quality features. Does that answer your question?
Is that okay? I'm sorry. Did you get it?
Yeah, I
Did you
get it.
understand what he's saying?
Thank you for the answer.
Okay. Thank you so much for the answer, Prof. I think she understood.
Okay.
Okay.
Sounds
I
good.
guess
Yeah, thank you. It's a very heavy topic for me personally because I come from a communication background and then now I have to deal with this edge computing. Oh my
Okay.
God.
I see. I
Yeah.
see. Yeah. Communication. Yeah. Okay. It's a little different.
Okay. All right. Thank you,
Yeah.
bro. Okay. I think we will move to the next question. Perhaps some students. Yes. Okay. Go ahead.
Introducing my name Angela from Informatic Engineering Study Program. Honorable the Professor Kewei, thank you for the material that has been delivered about data analysis, which is very useful. I would like to ask about individual identification related to fingerprint and facial records, which are very helpful in the world of technology to identify a person, but there is still fraud. For example, in facial records, there is still fraud on a person face, person voice, and fingerprints can be emitted. How to overcome this? Uh, and then for the use of fingerprints and facial records, will it still be used for the next 5 years? Thank you.
Uh-huh.
Prof.
Yeah, so I think your question is like how compare with like a working pattern with like
Fingerprints.
fingerprints and the face
Face recognition.
recognition.
Yes.
Yeah, that's a very good question. Very good question. So you think about uh, to identify like a working pattern, what you need to do is you just wear uh, like a sensor on your wrist, right? So you can make use of maybe your smartphone, and you don't. This we call this not intrusive, right? This is not intrusive. You just work naturally, so the algorithm will identify okay who you are. Okay, but if you use fingerprint and face recognition, you see that if I want to unlock this my smartphone, what I need to do is I need to put the smartphone in front of me, and then so this is called we call intrusive, right? So you have the user has naturally work by yourself. And therefore, so it cannot provide like continuously authentication. The same thing for the fingerprint. To do the fingerprint-based authentication or identification, you have to touch your finger with fingerprint reader, right? And then you need to make sure that this is available, but use like a working pattern. So this is less intrusive and and yeah, less available, and they can provide a continuously authentication.
Okay.
That's a major difference.
Thank
Yeah.
you, Prof.
Good
Do
question.
you
Yeah,
get
good
it?
question.
Prof, I have a question. Which one do you prefer for safety reason? Which one do you prefer? Is it face recognition or fingerprint? Which one is safer from your opinion?
From my opinion, so I think fingerprinting is safer, but then you have more constraints with the fingerprinting. Okay, so face recognition is more convenient.
Yeah, yeah.
So this is, for example, like my daughter can easily unlock my wife's phone.
Yeah.
Okay,
Okay, we got it. Thank you, Prof. Okay, thank you.
yeah,
Let's
Uh,
move.
yeah, happened like several years ago. Till now, she can still unlock my wife's phone because they have similar like facial
Okay,
structure.
yeah. Yes. You know, I have a similar
Okay.
face with my aunt, my auntie. So every time I want to open her phone,
Uh-huh.
I just put my face on it because we look similar, right?
Yeah,
Oh,
yeah, yes,
okay.
yes.
Thank you, Prof. Thank you. Let's move on
Uh-huh.
to the next question.
Sure.
Uh, yes.
Cek, cek. Baik, oh, baik sebelumnya mohon maaf kepada Ibu MC dan Bapak Moderator, saya berbicara dalam bahasa Indonesia saja ya.
It's fine. It's totally fine.
Jadi baik pertanyaan sebelumnya perkenalkan nama saya Ahmad Saiful Effendi dari program studi Sistem Informasi semester 2. Saya ingin menanyakan yaitu apa konsekuensi yang mungkin akan terjadi dari mengandalkan data yang tidak memadai untuk pengambilan keputusan yang mendalam di IoT. Sekian, itu saja pertanyaan dari saya. Terima kasih.
Okay, thank you very much. He is speaking in Bahasa, Prof. So we would like to translate
Yeah,
it.
therefore I got a little get lost.
yeah, because you cannot speak Bahasa Indonesia, right? All right, so it is actually consequences, right?
Oh, soalnya. Oke, diulang. Apa konsekuensi yang mungkin akan terjadi dari mengandalkan data yang tidak memadai untuk pengambilan keputusan di IoT?
So basically he's asking about consequences. Apa tadi? Apa konsekuensi apa?
Mengenalkan data
that you can rely only from a very small amount of data. Okay.
Yeah.
Consequences,
That's,
Prof. Yes. Yeah.
Yeah, that's
a
a good point.
Thank
That's
you,
good
Prof.
point. That's a good point. But the answer is yes. Even though like small amount of data, we can see that. So using algorithm, we can pretty accurately identify the user, right? So in addition to that, so we mentioned the like continuously authentication. Then yes, every small amount of data coming, so we use like a sliding window so we can do continuously identification. And then that can help us to prevent some of the misidentification.
Oke, thank you, Prof. Jadi bisa membantu ketika mengurangi kalau salah identifikasi orang itu bisa lebih mudah karena kan datanya tidak terlalu banyak gitu ya. Bisa
Terima kasih, Bu.
Oke, thank you, Prof. Ya, perhaps
We have one question again. Okay.
Good morning, everyone. Thank for the chance given to me. Now I will to introduce myself. My name is Marnila Dendeku. I am from Informatics Engineering undergraduate program. Now I will asking based on the material on cybercrime.
Oh, I'm sorry, Prof. I'm sorry. Oh, okay. Sorry. Oh my God. I'm sorry. I'm not a computer person. Please bear with me. Yes.
Yeah, now I can hear now again. Yeah,
okay.
I can
Thank
hear
you,
again.
Prof. Okay.
Okay, based on the material on cybercrime, I will asking why do ransomware and phishing attacks still often success despite increased cybersecurity awareness? Thank you.
Oh, I think there's some background noise. I didn't really hear
He
clearly
didn't.
about
Okay, baik, Prof. I think she will repeat the question if you don't mind.
Thank
Why
you.
do ransomware and phishing attack still often success despite increased cybersecurity awareness? Thank you.
The question is actually related to cybersecurity, if I'm not mistaken.
Okay, cyber security. So this seems like a very general question. Yes, cyber security. Yes, this is a very big issue. So we are working on like several.
I'm sorry, Prof. Sorry, Prof. Can you please repeat?
Yeah, we are working on several like cybersecurity related projects. One like user identification. So this is a part of like cybersecurity, right? How to identify the user. Okay. And two works I presented is related with cybersecurity. And the other like project we are working on right now is how we make use of like larger language models to detect intrusions. So I have a student working on PhD student working on that. In addition to that, so we are very much interested in like cybersecurity in like autonomous driving in robotics because you know uh, they they are not using like they are not only using like a traditional operating system but on top of traditional operating system, there's another layer called the ROS, robot operating system. So in that ROS, there's some like additional attack interface or vulnerabilities there. So therefore, I have some students they are studying like defending mechanisms for like robotic system.
That's very interesting. Thank you, Prof. It sounds really hard for me.
And also like it is, yeah. That's why we do
Yes.
research, right? Yeah, and also like a machine learning algorithm itself has some vulnerability because you can use some algorithm to attack them to to mislead the detection results. So we have some students working on that.
Okay, I think you get the point, yeah?
Yeah. Oh, very good question.
Thank you so much,
Yeah.
Prof. Yes, we have very smart students here in the auditorium. Yes.
Yeah,
Yeah.
that's great. That's great.
They are
Yeah.
really curious.
So if you consider to apply like American university, including UNT, yes, and feel free to
Oh yeah.
reach out.
Yes,
Okay.
yes, that will be really awesome. Yeah,
Yeah.
thank you, Prof. Let's move on to the next question. Oh, okay. This is like a question from a lecturer. He is now pursuing his doctorate degree. So his name is Ems, and he has two questions. It's
Yes.
about the public distribution ecosystem, such as agriculture or livestock.
Okay.
How can IoT?
Yeah. Oh, I see that in the
Yeah, in the
chat,
screen,
right?
in the screen, yes. You can read
That's
it.
good. That's good.
Okay, Prof. Yeah.
Okay. So yeah, so in the agriculture or livestock, how can IoT accurately identify users? Okay, such as the farms using only minimum data. I think for that, so you can make use of the algorithm we presented. That's could be one possible like solution for that. As in addition to that, also we are working on some like ECG, EKG based user identification. We are collaborating with a professor from Germany. Okay, so we can identify the user based on its ECG, EKG patterns. So therefore, this might be something interesting. Okay, if we want to like identify the farms or other like other like other users with minimum data. Okay, and he has another question is about integration of IoT and the blockchain technology. Okay, so that's a very interesting question. Yes, I would say, okay, so blockchain is a very interesting platform to be explored because they provide traceability, they provide a consensus, and they also, it's not like a modifiable system, right? By nature, by design. So therefore, so if you uh, want to make sure that okay, so all the IoT data collected could be like verifiable, traceable, then yes, you can use blockchain as the underlier like ledger to record like IoT relate data related activities. But as you know, so blockchain itself is not like a good database to store a lot of data. Okay, so therefore, I would suggest you uh, to only store some like IoT data related events or some of the hash and into the blockchain. And then later on, if needed, you can do some auditing to the collected IoT data to prevent the like it is has been manipulated or not manipulated. Yeah, we had some work. Okay, we proposed called a system called a uh, consortium blockchain. Okay, for security. So this work, you if you are interested, can send me an email. I can share the paper with you. See if if there's some interesting ideas to you.
Okay, thank you, Prof. Kewei. Maybe
Uh-huh.
participant on the Zoom meeting have questions. Can you ask him?
Oh yeah. Okay. Okay, I see the questions from Surma, right?
Oh yeah,
And
from Mr.
okay,
Sumarlin.
regarding NRMSD map, how does the selection and the combination of feature observed uh, affect the model ability to generalize? Uh, Deploy the surveillance cameras that need to operate under varying light. Okay, oh, that's a very good question. Okay, very good question. Yes, so for that, so I would say, uh, so if you want to work on this kind of complicated scenarios, and then the simple models might not be the great choice. So you might want to try like multi-attention transformers, okay, and then you can have the data from different scenario, but even like that, so the result, the result might not be great. Okay, we have some like student working on, for example, like in the autonomous driving. So there's some task called the perception, right? So perception is used to recognize the objects, okay, in camera or in a camera data or from cloud, on the cloud. But we found that so with under in the condition of different weather or different lights, actually, so that is very difficult to have a generalized model work for various data condition, have weather condition, or for various like light conditions. So therefore, so we 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 are working on something to have like adaptive models for different conditions.
Okay, Pasumar, do you
So does
understood? Did
that
you get
make-
it? I think
okay?
you answer it all perfectly, Prof. And it's so
Thank you.
amazing that you said that you wanted to share the data about it for the question that Pa M shared it with you earlier. So we really thank you for that, Prof. Yeah,
Thank you.
yes. Do
It's all great.
yeah, thank you. Anyway, do we need to end our seminar now, or are you still open to some questions, Prof?
Uh, I think that's maybe about the time. But if you guys have any further question, Maria, you have my email, right? Feel free to send
For
me
sure,
email
Prof.
and
For sure, for sure. I think before we close, before we end this seminar, I would like to, well, as a token of appreciation, Prof, we would like to present this hand-woven textile to you. Thank you very much,
Thank you.
Prof.
Yeah, I wish I could have a chance to visit you guys
Yes.
in future. And yeah, you welcome you to visit the UNT, to visit the United States as
Oh,
well.
so you are saying that it's like UNT opens a lot of opportunity for us to perhaps visit there.
Yeah, I guess so. So we can keep in touch
Keep in
and
touch, yeah?
explore some of the opportunities.
Yeah, and Prof, before we end our discussion, I would like to ask you, but is there any opportunity for not only you, but also perhaps your colleagues, teach us in the future about data or about AI by Zoom?
Yes.
Oh, thank
Yes,
you so
yes,
much, bro. We really
definitely.
appreciate that. Thank you very much.
Okay.
Before we end,
Thank you.
before we end our discussion, can we take a picture together? Like we put you on the big screen and then we just take a screenshot or something like that.
Oh, okay.
Yeah.
Thank you.
Thank you, bro.
Yeah, I
Yes.
should
I know.
I should change the address.
It's okay. We just send you
Okay, thank you.
the Tanun itself, so maybe you can make it later. Yes.
Okay, sure. Thanks.
Smile, Prof.
Good now, right?
Yes. We are taking a picture now. Yes. Smile. Can
Okay,
you just smile?
great.
Yes. All right. I think we are done. Once again, thank you very much, Prof, for your time. I will email you later on, and we will send it to you,
Thank
the
you, Maria.
textile later on. Thank you very much, Prof. Have a good evening.
Thank you.
Rest
Have a good rest
well.
of your day.
Yes. Thank you, bro. Bye-bye. See ya. Bye semuanya.
Bye.
Dadah. Bye, bro. Yes, baik. Kita beri tepuk tangan dulu dong sekali lagi. Masih semangat ya. Luar biasa. Terima kasih Prof. Kewei, terima kasih Pak Yampi, terima kasih untuk semua yang hadir. Words cannot describe how I am so thankful for this event. Thank you very much for being here. Semoga teman-teman semua bisa mengambil hal-hal positif. Jangan hanya snacknya yang diambil ya, tapi materinya itu yang paling penting karena itu sangat berguna bagi teman-teman untuk di kemudian hari. Dan tadi Prof. Kewei pesan, kalau teman-teman punya pertanyaan, silahkan sampaikan ke saya, nanti saya akan kirimkan ke beliau. Dan beliau akan dengan sangat senang hati menjawab pertanyaan-pertanyaan tersebut. Lalu yang kemudian, beliau membuka kesempatan untuk teman-teman yang mungkin mau berkunjung ke Amerika, ke Texas. Hey, we never know ya. Jadi mungkin teman-teman nanti makanya kuliah yang benar, kuliah yang betul supaya bisa dapatkan beasiswa, peluang mungkin sekolah keluar. Nah, Profesor Kewei membuka kesempatan untuk bertemu beliau secara langsung di Texas. Oke, dan yang ketiga, beliau juga membuka kesempatan, tidak hanya beliau, tapi juga teman-temannya untuk mengajar kita secara online di kemudian hari nanti. Nanti itu urusannya bersama jajaran pimpinan. Jadi teman-teman harus semangat ya, semangat? Oke, nanti improve bahasa Inggrisnya, kita latih lagi supaya kita bisa mengikuti perkuliahan internasional lainnya. Saya pikir itu saja Pak Yampi, mungkin ada yang mau disampaikan?
Oke, dan ini merupakan dari program studi untuk seminar internasional. Dan juga ada seminar-seminar yang lain yang nanti akan kita ikuti bersama. Untuk itu mohon partisipasi dari semua mahasiswa. Dan pada link yang sudah dibagikan untuk presensi, untuk dapatkan e-sertifikat, mohon segera diisi. Dan mungkin panitia bisa membagikan kepada teman-teman perangkatan atau di grup program studi yang hadir bisa mengisinya sehingga menjadi bagian keterlibatan dalam kegiatan ini. Dan nanti e-sertifikat akan dikirimkan ke email masing-masing. Ya, mungkin itu dari program studi. Mungkin ada dari Wakil Ketua 1 bidang akademik, disilahkan.
Oke, selamat pagi buat semuanya. Oke, itu tadi beberapa pemaparan materi yang disampaikan oleh pematerinya langsung dari luar negeri ya, dari University of Texas. Jadi harapan saya apa yang sudah disampaikan tadi terus diingat. Untuk diketahui bahwa teman-teman peserta kan masih semester 2 itu, atau semester 4. Nanti di semester 5 maupun semester 6, materi-materi yang disampaikan tadi itu lebih akan dispesialkan lagi, akan lebih detailkan lagi oleh dosen-dosen pakar di sini yang tentunya keahliannya dalam bidang machine learning, deep learning, atau IoT, ini seperti Pak Yampi, ada Pak Franky, dan lain sebagainya. Oke, kalian simpan saja dulu materinya. Nanti baru kita mainkan di semester 5 maupun semester 6. Sekali lagi terima kasih saya ucapkan kepada teman-teman panitia juga, terima kasih banyak. Kita beri aplaus dulu untuk teman-teman panitia. Oke, walaupun kita dihadapkan dengan jaringan yang kualitasnya rendah tapi tidak masalah. Karena kenapa mesti direkam, foto dan lain sebagainya, ini nanti akan dijadikan bukti untuk reakreditasi program studi kita. Dan semoga dengan adanya seminar internasional ini, nanti 3 tahun atau 4 tahun lagi program studi kita akan dapat unggul ya, atau akreditasinya A. Tepuk tangan semuanya. Oke, mungkin SI 2 tahun kah? Oke, mungkin itu yang terakhir, mungkin kita tutup dengan sesi foto ya Bu ya. Foto. Mari ya, foto bersama.
Oke, terakhir, besok kita masih ada seminar yang sama di ruangan ini dan berharap besok itu tamunya onsite dari General Bank Indonesia, dia setara dengan gubernur, kemudian dari DPR RI, Komisi 4 itu akan hadir. Harapannya dari program studi dari akademik berharap semua yang hadir ini ya, gunakan alma mater, dan kalau bisa kursi bagian depan itu jangan dikosongkan. Bisa kok? Jadi yang terlambat yang ini langsung isi bagian, mungkin ada baris depan Bapak Ibu dosen, baris kedua dan ketiga kalau kosong itu langsung isi tanpa ada dikomando lagi. Bisa ya? Oke, terima kasih. Sebelum selesai kita foto bersama. Mungkin kalian semua berdiri. Fotografer bisa ambil dari atas. Ya, semua berdiri dulu, semua berdiri, lihat kamera.
Saya di tengah. Ayo yang boleh maju ke depan teman-teman, berdiri. Biar kita rame-rame. Ayo teman-teman panitia juga, ayo silakan. Yang lain bisa duduk. Yang lain bisa jongkok di bawah mungkin biar rame. Ayo guys, ayo, time is kicking. Ayo. That's not how you translate. Parek. Ayo, guys yang di belakang, ayo berdiri dong. Ini kita minta foto bersama. Elsie mana? Ayo sini silakan. Ayo. Oke, kita bikin video. Nanti saya bilangnya gini, Stikomu Yelindo Kupang, teman-teman jawabnya mengangkasa membawa harapan bagi negeri, ya. Lalu diakhiri dengan bentuk huruf U. Coba kita latihan dulu. Kita latihan dulu ya. Ayo teman-teman yang duduk, yang apatis tidak apa-apa. Oke ya, kalian
semua berdiri. 1, 2. Yang paling belakang.
ayo ulang ya, kita latihan dulu. Kita latihan dulu. Saya bilang, Stikomu Yelindo Kupang mengangkasa membawa harapan bagi negeri. Ulang-ulang sekali lagi. Stikomu Yelindo Kupang mengangkasa membawa harapan bagi negeri. Tepuk tangan langsung itu ya, rame-rame. Oke. Tarik siap. Harap tenang. Harap tenang, yang lain kalau tidak berbicara, harap tenang guys. Nanti tepuk tangan terakhirnya harus heboh ya. Ya jangan sekarang, nanti. Siap? Stikom Uyelindo Kupang mengangkasa membawa harapan bagi negeri. Baik, terima kasih semuanya.